Maybe live. I think we're live. Let's check out. Okay, you guys, let me know down there. We have video and camera and everything else. Looks like we have card. Okay, so good. Okay, we have a lot to talk about tonight, but first things first, welcome to another week of live chat. We're going to talk about the weather, about climate, about everything that's going on in the atmosphere, and of course, taking your questions and answering everything. Boy, we've had a lot of interesting storms and evolution over the past couple of weeks and days. Heck, even this afternoon, we had a heavy one thunderstorm just basically sat over Philadelphia and southwestern New Jersey and produced very heavy rainfall just off of a old outflow boundary. That is the type of weather pattern we are in, and we're going to be remaining in it for quite some time. But first, I need to address social media. Social media is like a really annoying cousin. You kind of need him, because he's kind of helpful with setting up the computer and he's family, he's always been around. But you really want to punch him in the mouth sometimes, okay? That's how I feel social media is like. Now, obviously, I built this whole company. Everything I have here is based off of what I've done over social media. So, over the past few months, I think stuff's been going on Twitter. And as much as Twitter gets a lot of bad raps, look, Facebook, YouTube, all the others, Rumble, this, that, they all have issues. Okay? Depending on some people's point of view, social point of view, some like one over the other. And to me, the simple question is this: what's going to give me the most reach? Okay, what's going to allow me to share information the best way possible? And that's becoming more and more difficult. On Twitter, I don't know whether or not the people who usually follow me are actually going to be able to see what I'm doing. Then this new Threads thing that just came out, actually it's connected to my Instagram, so it was pretty easy to set that up. I set that up in like 5 minutes. It was automatically already part of my profile, so I guess I'm on Threads. There's another one coming out. What is it? In a couple of days, I think, or a couple of weeks. I know there's a blue sky, blue bird, something like that. I don't know. Every day. And you know what? This is good because competition's good and it's only going to force everyone to be better. But at the same time, it's a pain in the neck because you try to reach as many people. And to me, this isn't a statement on anything other than the fact that I run a business in which the most important part, even outside of money, just from a aspect of reaching as many people as possible, it gets very complicated. So here's what I'm going to do. I'm going to be on as many as I can. Okay? I'll be on Threads. I'll be on Twitter. I'm not leaving Twitter. I don't know what's going to happen to Twitter, but I'm not leaving Twitter. I'm on YouTube. And I'm on all of those things. And I'll continue to explore Discord. Yeah, well, I'm going to bring that up in a minute. I'm on all sorts of different avenues, right? But if you want to be sure to follow me and to get the latest information, Discord. I'm on Discord, and the thing that I like about Discord is that I control it. So you could say whatever you want on it, depending on what channel you're on, okay? Just be nice. Nobody be rude or angry. You can even ask for tornadoes 1 billion times, believe it or not. And there's a premium section for premium members, and there's a public section for everybody else. So if you're not a subscriber, that's fine. You can still see my latest thoughts. And what I normally do on Twitter, I'm going to be doing in Discord, and then copying over to Twitter and Threads and all those other, because I don't know who is going to see what, but I can guarantee you'll see it on Discord. So that's basically what I'm planning on doing here. I started setting this up back when Twitter got bought, just as a backup, not only because of Twitter, but because YouTube has weird algorithms where if you say climate change, it might shut down your video. And if you don't say it, then it might shut down and it might limit your views. Who the heck knows? The rules change everywhere every 5 seconds. All I can tell you is that if you want the latest information from me, you can follow the website and you can follow Discord. That's the best I can do. In the meantime, a bunch of billionaires are going to figure out what social media works best, or they're going to shoot each other off to Mars. I don't know. But that is where we stand right now, because I got a lot of emails and a lot of questions about that. And there's a lot of stuff going on with all sorts of fight back and forth. So I don't know what the future is. And it's important for me to discuss this with you right off the bat, because that's how I built the business. The whole business, the whole reach, everything that is NY and JPA Weather is built on social media reach. And one way or another, whether it was via the old weather bulletin boards and chat rooms, or the start of Facebook and Twitter and all that stuff, that's how I started off all this. So now, if you want to see me, and you can 100% be confident to reach me, I will be on Discord and everywhere else. But definitely check out Discord, regardless of what happens in social media land. So I wanted to knock that off first, just so that way everyone understands. And we are live on Twitter right now. I don't know whether you can see me or not. I don't know whether you can respond or not. I have no idea whether or not it disappears. I don't know. It's as confusing as water vapor in the stratosphere right now. Complete chaos. So that's where we are right now with that. Now we got that out of the way. And oh yeah, I like I said, I joined Threads. I have no idea how to use it, but a lot of people have already started following me. So you can follow me there, I guess, as well. Same handle, NYNJPA Weather. So there you go. Alrighty then. So what should we talk about? Maybe this active weather pattern. Now, first, let's get this over with, the tropics. There's nothing going on. Nothing. Strong shear, a lot of dry air. Gee, where's all those posts and all that anxiety about the fact that we had 3 storms by June? Zero. It is completely mute. Why? Because of what I warned everyone. Don't jump the gun on the tropical season when you have a developing El Nino. Now, this El Nino is weird. Well, what hasn't been weird this year? So, yeah, we have our warming taking place here. You have your clear development of an El Nino signal here. In Nino 3.4, you're approaching 1 degree Celsius. The Australian numbers are closer to 1 than the CDAS numbers, which is interesting. There's a lot of back and forth on terms of the reliability of these numbers, but they're within the same ballpark. Basically, Nino 1 plus 2 is the warmest at 2.8 or 2.5, depending on which one you want to follow. 3 is down to about 1.3 to 1.25. 3.4 is around 1. And Nino 4 is around 0.5 to 0.6. Okay, so not too bad. So this, you would say to yourself, gee, this looks like an east-based El Nino. No problem. But it's not acting like an east-based El Nino. In fact, convection acts more like a west-based El Nino, which is important when we start to discuss all the different factors involved with forcing in the atmosphere. Meanwhile, the Eastern Pacific, which is normally very active during El Ninos, along the Western Pacific, has been pretty much dead quiet, which doesn't make much sense. Then you throw this in. This will really throw you for a loop. Now, remember what I mentioned about the SOI being the primary factor in how the atmosphere responds to the El Nino development. So you would think, oh, look, it's going to be negative. Boom. It starts going positive for several days. And it's not driven by the MJO, which is neutral. So I'm kind of here scratching my head here saying, what in the heck is going on here? So the atmosphere is responding almost with a neutral state in the monthly values. Still a negative state in the seasonal values, but very weak. But the 500 millibar pattern is very El Nino-like. So what we have going on right now is a ton of different signals. So what we have to do is figure out why. Well, we know that we have very active sunspots going on, the highest in 21 years. Impressive stuff. Why is that important? Well, the more activity we see with the sunspots, the more impacts it has on the upper stratosphere and the ionosphere. So that's a possibility. Certainly the activity going on there helps to destroy more ozone, leads to more cooling, which in response could lead to a change in an unexpected influence on the 500 millibar pattern. And of course, as you know, we have a ton of water vapor in the stratosphere. Meanwhile, we have these ozone concentrations that look something more like what you would see during the fall months than you would in the summer months, as in these pockets here that are built up. So that's kind of unusual, and that's been driving our upper level lows. But that doesn't answer everything either. It's a mystery. And boy, do I love mysteries. So what about sea surface temperatures? All right, well, let's see here. Let me pull up that data here. And we have a heck of a gradient here in the Pacific. We have, you can't really call it a positive or a negative PDO. It's kind of a mix of two. And then we have a very warm Atlantic. Okay. So the very warm Atlantic should continue to enhance cyclogenesis over the northern hemisphere and support the development of the thermal contrasts to support your upper level lows, in theory. The Pacific, though, look at all these gradients setting up. This gradient configuration could be what's enhancing the polar and subtropical jet streams. At the same time, we'd had convection really fire up, and now it's starting to back off because of the SOI signal. So it seems that we have a lot of conflicting signals here fighting against each other. And because of these conflicting signals, you get this evolution in the jet stream, which, let's see here, pull up, where is my data? Here we are. That we are seeing here at 250 millibars. Look at all these jet streaks here. You have plenty of amplification of the polar and subtropical jet stream. You're having parts of the subtropical jet stream get transported all the way up into portions of Greenland. Why is that important? Well, it's transporting a lot of tropical air, and you have subsidence that's pushing your high temperatures in some locations around portions of northeastern Quebec and around Greenland into the 80s and 90s. Interesting stuff. It's also sending down some polar air into the central part of Canada, which further amplifies this whole pattern. So we have weakening convection in the tropics, but an enhanced thermal gradient enhancing our weather pattern. A continuation of an amplified polar jet stream, possibly driven by some stratospheric influences with the above normal water vapor and the increased sunspots that we're seeing. While all this is happening, we're seeing a lot of wave breaks and basically these stronger storms setting up with deep upper level lows that you typically see more in the fall than you do in the middle of the summer. And this, as a result, is leading to a lot of strong to severe thunderstorms, which leads us to where we are now, where for right now, we have a nice ridge axis over us, giving us a break. But even during our break, we're still getting isolated thunderstorms setting up around the Delaware River Valley, all driven by factors like old outflow boundaries, sea breeze fronts, which with all this tropical moisture in the atmosphere, I mean, this is some deep moisture still in the atmosphere. This is after a cold front passage, you're around 1 to 1.5 inches in precipitable water value. This is typically what we see in an average summer. This, again, is more like when we get like one of those hot and humid weather patterns where like you're talking about 95 with a dew point of 70. No, now this is becoming the average. And you're seeing this moisture transport taking hold. And that is what's helping us drive these thunderstorms, producing these impressive rainfall rates. And I think because of the increase in the precipitable water values, we're seeing an increased potential of seeing more tornadic thunderstorms. But I want to touch on that. I was going to touch on this, but one of the things, let me see here. Here we are. Okay. This one and this one from the American Meteorological Society. This is from Charles A. Dozel. And this is from American Meteorological Society, Peter S. Ray, right here, who headed it. These two books. If you're interested in thunderstorms, you want to get these books. They're from the AMS. They're easy to find. Go to the library in the AMS. I've been studying these two to try to figure out this whole tornado issue, right? How to forecast for them better and all that stuff. And what I found is something interesting. When we're seeing this above normal precipitable water value, and you include the equations, you increase the potential for torque in the atmosphere. The torque, which is basically turning in the atmosphere, is further enhanced by our low-level wind dynamics, like the urban heat island effect, right? So it looks like we're starting to get this combination of factors, but the key thing is to pinpoint where. Now, this doesn't mean that no one's going to see an isolated tornado or so over the next couple of weeks and months ahead. But if we study where this gradient constantly sets up, and we study where the urban heat island is, and we study where the thermal gradient is at the surface, and let me pull that up here. So you want to study this map. Surface temperature, dew point, and pressure. And what we have been constantly seeing, and we are seeing it right now, there's your urban heat island effect. There's your bulge, right? That bulge is setting up this gradient right here. You see that? See how this kind of packed right in here? Well, that's been a constant theme for the past couple of months. I saw it in February. I saw it in March and April. May. I've seen it last year and the year before. This gradient that keeps on showing up that I'm showing you tonight, and we'll keep an eye on it and study it and see if we continue to see it as a forecast header of potential tornado activity, keeps on showing up in the western suburbs of Philadelphia. And that gradient somewhat gets up to around the New York City suburbs. It's not as strong. It's really strong down here. And this gradient with these winds, notice we got winds from southeast, south, southwest, and then as we go into the upper levels again, we got winds that typically are coming in from the southwest, like when this trough approaches. We'll keep an eye on that. When you see that evolution take place, we have vertical wind shear and vertical speed shear. So there's your turning. Then you throw in the above normal precipitable water values. So now you increase torque. You throw in the increased potential for lifting because now we're on the lee side of the trough. We have more divergence and diffluence. Everything's rising faster and turning. And you add in the above normal moisture. You throw that in and mix it up and you get brownies. No. What you get are thunderstorms that are dynamic, that are capable of producing strong downburst wind gusts, and that downburst wind gusts is producing vortices, what we call mesolows. Okay, tiny little lows. Okay, kind of like mini cupcakes. Okay, so we have little tiny lows within these thunderstorms, and that's what we're seeing with these tornadoes. Now, with those mesolows, the National Weather Service, and rightly so, is warning pretty much almost every mesolow we see. That produces a lot of false positives. Okay, you get a lot of these thunderstorms that are warned as tornadoes, but they don't reach tornado status. Maybe they produce a wall cloud, or they produce a base of a funnel, but not a full tornado. Again, we're not in Tornado Alley, i.e. the plains, where we have a lot of room to work with and a lot of time for these thunderstorms to develop. Because the coastal plain right here has a lot of stable air naturally from the ocean. So there's only so much time it has to actually develop. So it's got to do it fast. But I think because of this environment, we're going to see a lot of false warnings, but it's better to have a false warning and be prepared than no warning at all, and then you get whacked with one of these storms. And you don't only have to have a tornado to have significant damage. These storms and this type of turning and these type of mesolows also produce what's called strong downbursts, okay? So basically downbursts is when you have all that rain-cooled air slam into the ground, and when you slam it to the ground, what happens is that it slams to the ground like a hammer, right? So that hammer can spread out then and impact and cause straight line wind gusts and a lot of damage that way. So you should still be prepared when you interact with those thunderstorms and you get that tornado warning or severe thunderstorm warning. So I think that's what's happening here in that respect. Now we could talk about all the factors going involved in this. Yes, you can touch on climate change. You could touch on a lot of different factors going on here with this respect. There's a lot that needs to be studied here. It's very interesting stuff. But that gradient, this right here, I'm going to be watching this. I've been watching it for a couple of weeks now, for a couple of months, heck, for a couple of years at this point. And moving forward over the next 6 to 8 weeks, really through August into September, we're going to watch to see if that signal keeps on showing up and whether or not that produces that tornado signal that we've been seeing. Even when you would think that the atmospheric conditions aren't favorable for it. I think that's the signal. So I'm going to be keeping an eye on that, and I hope you will too as well. Now, as far as our weather pattern going forward, well, if you don't like humid conditions or thunderstorms, I got some bad news for you. It's not going away anytime soon. We continue to see this pattern continuing to fester. You will see a little bit of a relaxation, but not much. Basically, we get rid of our upper level lows for a short period of time, but just keep the trough. But the results are all the same. A lot of humidity, a lot of mugginess. Your overnight conditions will feature fog. And, by the way, let me see if I have the data here. Oh, right here. The potential for fog is pretty high for the coast. I mean, look at that visibility falling to near zero along Long Island, South Shore Long Island, the Jersey Shore. Don't be surprised that it gets more extensive. You can see it forming in the valleys for tomorrow morning. So if you're traveling tomorrow morning or overnight tonight, do not be surprised if you're dealing with some fog with all this moisture in the atmosphere. So there's a lot going on here. A lot of interesting stuff. Again, the tropics are quiet, but we certainly are not. So with that, I am going to take some of your questions. We'll see how we go. We don't have a Mets game on right now because they're in the West Coast and they're playing an ungodly hour. So I won't be ranting about the Mets this week. I could if you ask, but it's a good break. So Twitter stuff may be related to what came out regarding Google today, which started, it's going to scrap the entire internet for info. Boy, all I can say about Google is did anyone learn anything from Terminator? Really? Come on. We gotta chill a little bit. The only way to avoid that is to make stuff no longer public. Yeah, that's almost impossible. I mean, it really is impossible to have. You basically have to go offline, not buy anything, and like live in a cabin in the woods, buy a van by the river. So that's pretty much it. Northern Hemisphere is rather devoid of tropical systems at the moment. The Atlantic is expected from shear from El Nino, but the Pacific just wow. Yeah, it's very surprising with how quiet it is. I was not expecting that for the Western Pacific. Eastern Pacific, usually you see an uptick, but it's been very quiet. I'm shocked by the Western Pacific, though. That's really surprising the heck out of me to see. Basically, let me pull up, see if we have any storms to keep an eye on here. Nothing. I've never seen it like this in the summer. Usually somewhere, Indian Ocean, Pacific, somewhere you'd have something. But we got nada. I mean, the Pacific, it's quiet. There's no place to look. I'm shocked. I'm not sure what to make of that. Perhaps it's a strong vertical wind shear. Maybe that's a factor. Maybe what we're seeing is the influence of, let me see here. Pull up the right one. Here we are. This jet streak right here may be ripping apart our tropical systems in the Pacific. But that really doesn't answer why we're seeing such a devoid of activity in the Eastern Pacific. So, yeah, I mean, it's very, very unusual. That is for sure. I do think cutting off the severe storm and tornado Twitter feeds to non-Twitter users is a real disservice, but limiting public access is the only way to protect from what Google announced today. The question is what to do about it. I mean, I don't know. I honestly don't know. I mean, you have to get public information out, right? I mean, you do. You're talking about severe warnings. So possibly the best way to do that is simply going directly to the source, if you can. Looking at 250 millibars, even as the jet streaks themselves are a bit relaxed, still lots of wave breaks and tiny little upper level lows on the edges. Yeah, we should see a relaxation, but I'm not saying a collapse. We're going to continue to see the continued theme of a trough around the Aleutians, a trough on the west coast, a ridge around the plains and around the Rockies, and a trough over the eastern United States. Our pattern's going to remain active, just not as amplified as what we've been seeing. Can't recall seeing the Indian Ocean with the number of pockets of warm and cold waters that we have at this moment. Yeah, I mean, there's a lot of unexpected and really unusual observations of late. That is for sure. I mean, I don't think there's any way of denying that with what we're seeing here. And it's hard, maybe this has part of it to do with the influence of the reduction of sulfates. I've been reading about studies about that, and maybe that's why we're seeing what we're seeing, but I don't think it's a 100% complete answer. But there's a lot here that, quite frankly, stumps me right now. Did any rain get into the areas in Canada having wildfires? Not that I've heard of. Not anything substantial, at least. Is the urban heat-on effect impact bulge that Philly gets less in the New York area because New York City is so close to water and gets a sea breeze much more often? I think, and let me go back to the observations here. Let's see here. I think you still see somewhat of that bulge here, but I think there's so many competing factors around New York City with the sea breeze, with the influence over northeastern New Jersey, and your buildup over southwestern Connecticut and portions of the Hudson River Valley, that it's a little bit more muted. But the Philadelphia metro, you really have that strong concentration, and then you have the Pine Barrens in on the Jersey Shore, and then your rapid reduction of concrete and large towns over southeastern Pennsylvania compared to what you have over northeastern New Jersey. That I think that you get a more amplified influence around the Philadelphia metro and the Delaware River Valley. I think. At least that's my idea. Interesting about the gradient effect. Sunday around 6:30 p.m. we had a tornado warning storm in Lehigh County. I saw a couple of radars, saw an impressive inflow, a pedestrian cloud. It tried to form a warm cloud, then boom, collapsed 10 minutes later. Yeah, these are going to be very unstable storms. They're not going to be the type of storms that you've seen in the plains. But one thing I have been noticing, which is something I never thought I'd see, to be honest with you. In the plains, when I was out in Oklahoma, I used to see this all the time, called mammatus clouds. It looks pretty cool. It looks like little, I don't know, how would you describe it? Like little bulges in the clouds, right? It looks really cool and really interesting. I never really experienced it living in New Jersey growing up here. And I didn't experience it much when I came back in 2006. But over the past 3-4 years, I've been seeing this influence more and more, this cloud type more and more. And it's an indication of rapid rising and sinking air in the atmosphere. And it's usually a hallmark card for severe thunderstorms. So, and dynamic thunderstorms at that. So it's interesting to see that cloud pattern show up more and more, and just kind of illustrates the instability in the atmosphere that we're seeing. Now, let me check out YouTube and see what we got here. Let's see here. Will this weather pattern have any effect on the wildfires up in Canada throughout the U.S.? Not much, unfortunately. Haven't heard much of an improvement. So unfortunately, until the Canadians get their act together and put out that fire, we continue to be under the threat of getting some smoke. Again, nowhere near what we saw last time, but I can't rule out with the northwesterly wind falling back under that smoky haze factor, which becomes even worse with all the humidity in the atmosphere. We had a weird winter, now we are having a weird summer. What's next? Godzilla. I'm going to go with that. Anything on Twitter, hon?
Nope.
Okay, that works. We got more questions here in the live chat. Let's see here. I remember seeing mammatus clouds in my part of New Jersey over the years, but if anything formed, it usually was a weaker one over the Queens of Long Island. It's been a crazy year, that is for sure. A rough summer for traveling? Oh, absolutely. All the severe weather leading to a ton of flight delays. Yeah, when it comes to flying right now, personally, I get there 2 hours early and prepare for the worst. You know, I have a backup plan just in case. There's not much you could really do. Flying right now has been a real mess. There's no other way to put it. Now, I'm curious, as far as Twitter is concerned, you know what, let me try and see if I can pull it up here on my own. Cause I'm just curious as to whether or not it actually shows up or not. You know, let's see. Yeah. Oh, there it is. All right. Well, it didn't block that, so that works. Again, you just don't know. So, a lot of interesting evolution in social media, that is for sure. But definitely, I do want to say, I want to thank everyone that's following tonight. I mean, look, it's relatively quiet night. It's summer. Usually we don't have a lot of people, which is normal. What?
So people are recovering from 4th of July.
Well, yeah, that's definitely true. So I want to thank everyone who is here. I really do appreciate it. And I hope that I answer your questions the best way possible. And go from there, right? I mean, right now, this pattern is one where a lot of people look for direct answers. Like they want to like say, is my summer party going to get rained out? I have a wedding this date. I have a party on that date. Well, here's the thing. The only time I can say to you that there'll be a limited threat of thunderstorms is when I have what's setting up for tomorrow, which is basically a ridge axis right over us. When you have that, it typically leads to quiet conditions. But overall, this pattern features troughs to the west of the region. And what that means for us is that we have these constant influence of short waves moving through and the potential for thunderstorms every day. Let's see. Snow. All right, Snow Boss. Let's talk about snow. Because I know that we have already started to see some of the winter forecasts and whatnot popping out there. I will say this. The development of El Nino over the next 6 to 8 weeks will have a huge influence on the forecast for the fall and especially the winter. Because in the next 6 to 8 weeks, we'll find out just how strong El Nino will be. And once we have an understanding of that, then we'll have an understanding on the base influences of the winter forecast. Anyone issuing anything before that, they could be walking into a big mistake or get very lucky in nailing the state of El Nino. Right now, the model guidance is split between a moderate El Nino and a super strong El Nino, as in like over 2.5 degrees Celsius above normal in Nino 3.5, which would be one of the strongest El Ninos ever. So one moderate would probably make people like Snow Boss very happy. Super strong, probably not. Okay, so we'll be keeping an eye on that, and hopefully we'll have a lot more answers to that question moving forward over the next 6 to 8 weeks. Seems that dry boundary layer won't be an issue when it comes to convective precipitation for a bit. Yeah, that's pretty much been voided out of existence with all of the thunderstorms. That dry boundary was overwhelmed so much by all the scattered showers and thunderstorms that it literally has disappeared. There's some faint hints of it down towards southeastern New Jersey, but I think that's driven more by the stable boundary layers involved with the Atlantic Ocean causing those thunderstorms to collapse than any type of dry boundary. I think that is the primary factor influencing those thunderstorm trends. Let's see. We have a lot of great questions tonight. This is outstanding. Supposed to be heading to Zurich in 2 weeks. Well, good deal. Assuming my flight can actually leave, well, that's a good point, I'm hoping for slightly less oppressive weather out there. Oh, well, I'll put it this way. If there's a trough around the East Coast, there's probably a pretty impressive ridge. So the humidity might be lower, but it might be a bit hot. Sorry. Hopefully you have a good time, though. You know, I heard it's beautiful out there. Personally, I don't travel all that much. I did all my traveling when I was younger. Now, for me, a vacation is staying home, watching CSI, or watching the Mets. Right, hon? Staycation. Staycation is the way to go. Because then you can order your favorite food. You don't have to go anywhere. You don't have to worry about your luggage being lost. It's great. That's my personal opinion. But some people love to travel. Stay in your pajamas. There you go. Going to Hawaii in 2 weeks. Tropical, not humid. Hawaii, right now, looks to be absolutely perfect. No sign of any storms. Should be pretty nice. Of course, then there's always a volcano, but, you know, they got that going for you. But I think it'll be pretty nice out there in Hawaii. Now, as far as any type of break in the pattern, I'm really not seeing anything that really stands out. In fact, here, let me pull up the long range data. Now, typically lean on the European guidance on this because it has been performing the best for the past week, month, year, or years. You know, I like to use the best tool. I do use the GFS and GFS ensemble guidance, but I don't rely on it, to be honest with you. I find that it causes more errors than not, especially when it comes to tropical development, as you all know. Now, through July into August, the general theme continues to be broad trough over the Pacific, broad ridge over the west, or especially over the Rockies, and a trough here. Now, what's interesting is this ridge out here. If we get a tropical system, doesn't even have to be a hurricane, let's just say a tropical depression or just a tropical disturbance, we're going to have to really keep an eye on anything that's going to be sitting up here and any trough sitting around here, because the combination of these two could lead to a significant rainfall event. Other than that, the overall theme that I see is basically what you see right now is what you get all the way through the summer. So, I mean, I want to give you guys a little bit of glimmer of hope of some cooler conditions, but that might not be until we start talking about football. So, it's going to be a bit. Latter part of July will be another AC trip. There you go. Definitely have fun doing that. Let's see if we got any more questions out here on YouTube. No, looks pretty quiet. Wrong season for this kind of setup. We need this in the winter. The age-old, what would this pattern look like in the winter? This pattern in the winter, let's just say it's a carbon copy. It probably wouldn't make you very happy. So why? Well, for one, let's zoom in here. For one, your ridge axis is a little bit too far east. Your trough axis is a little bit too far west. Or should I say east as well. I need more coffee. This trough here is a bad signal. You see, this trough here would kick anything that develops out into the Atlantic. This pattern in the winter is a cold, dry pattern, and a whole lot of mist storms, and most likely 3 or 4 days of hype from the GFS and the European of potential storm that just ends out to sea. What would we need to make this a more favorable pattern? And this is something we're going to be having to watch out for with an El Nino. In this state, the subtropical jet stream kicks out any type of high latitude blocking. So it displaces the polar vortex and it limits your potential of building heights around Greenland. That's why you get a progressive storm track. So what we want to look for in the winter, and what all you snow lovers want to see, especially for business opportunities, snowplow removal and whatnot, you really want to see a strong upper level low around the Aleutians. If you get that locked in, then that amplifies the whole pattern and pulls this trough axis back towards the Mississippi River Valley. If you get that set up, then whether or not you have a negative NAO or not, or i.e. blocking, you still have the potential for storms to track towards the Delmarva Peninsula and towards the benchmark. So what we're going to be watching as we head into the cold season is the state of that upper level low around the Aleutians. That's the traffic cop that you want to be rooting for if you are in snow removal this year. And I know it's been a tough period of tough couple of years in terms of snow removal and whatnot, but that's going to be the key. Now, I'm going to be dead honest with you. We won't know that answer until we get into October, because part of that revolves around the state of the stratosphere, troposphere connection and interaction, right? So what you'll probably get is a lot of promises of that trough and follow, you know how the industry works. So that's where the forecast is going to have to be based, because you have to amplify the pattern. Then there's the question of high latitude blocking. If you get convection around the dateline, you get a disrupted polar vortex, then things can get interesting. But there's a lot of ifs and buts that we have to work out. But yes, it has been a rough time period. I know a lot of people are looking for positive answers. I'm just going to give you the honest answer, which you might not want to hear. If we get a very strong El Nino, you better hope that the polar vortex is blown apart in December, because if it's not, then it's going to be a mild winter, or at the very least a very below average snowfall winter, because you won't have the high latitude blocking, and the subtropical jet stream will overwhelm the polar jet stream. So what you want is a El Nino somewhere in the ballpark of 1.0 to 1.6 Celsius, moderate to strong. Then you could develop the high latitude blocking to make some interesting storms. But if you get like something like a 2.0 or 2.5 degrees Celsius El Nino, forget about it. That's just the truth. And the disruptive polar vortex goes right in the right direction orientation. Yes, that's key too. I mean, there's a ton of keys, but yes, that's also an important factor too. My unscientific reasoning is we can't do much worse than last year. Yeah, well, that's true. You can't do much worse than zero. That is true. You can't go negative. All right, let's see. We have some activity here on YouTube. Steve, can you explain the capping inversion and how it affects thunderstorms production in New Jersey? What site do you use for your models? All right, so for models, there's a lot of great free ones out there, like Tropical Tidbits. Definitely great. For paid data, I use weathermodels.com. I've always found it to be reliable. They have a lot of great data, a lot of great resources. It just kind of depends on the display you like to use. People have different types of displays. Me being colorblind, I don't need a ton of color displays because I can't see them anyway. And what I like about weathermodels.com is that I can look at the data and still use it, and it doesn't rely on color code alone. I could look at the data itself and pick out the gradient. So that's always something. Now, in terms of capping inversions can be a tricky thing. Okay, let me see. I can pull up my chart here, and I'll fix the camera so that way you guys can see everything. There we go. Oh yeah. Hello. There, I just drag this thing. I'll learn how to use this properly one day. I don't know when.
Just have to lift the latches. Never mind.
Oh, there they are. Oh well. Okay, so when we are looking at an atmosphere, when we have thunderstorms going off, basically, and we'll draw the surface right here, your temperatures, your parcel in the atmosphere, is able to rise steadily in the atmosphere because the parcel, this piece of water vapor, is warmer than the surrounding atmosphere. Okay? So this allows your thunderstorms to grow because this piece of water vapor here is constantly rising. So this is why when it's 89 degrees out and we talk about convective temperatures, what that means is that at the surface, the air at the surface is so warm that it's naturally rising without a forcing mechanism like a cold front or something of that nature, that the water vapor is able to rise all the way up to the top of the atmosphere. As a result, you end up with thunderstorms growing. Now, in a capping environment, you have an area in the atmosphere. Let's say right around 850 millibars to 700 millibars, that is warmer than the rest of the surrounding atmosphere. So the parcel starts out warm, rising, and remember, while the parcel is rising, it's also modifying. Okay, it's also starting to match the surrounding atmosphere, but at a slower rate. So while it's rising, it's cooler at this point than at this point because of that rising motion. Again, when your parcel is rising, it's cooling. When a parcel is sinking, it's warming. So that's why when we have very hot days where you have temperatures spiking into the mid to upper 90s, on the water vapor, you normally see this. Sometimes it's red, sometimes it's like a yellow signal on the water vapor. That's sinking air, and that sinking air is warming. Well, when the parcel is rising, it's cooling. So it's cooling, but not at the same rate as the surrounding atmosphere, so it's still able to rise. But as it's rising, it runs into this roadblock right here. And so the parcel becomes the same temperature or is cooler than this area right here. And so what happens is that the thunderstorm can't develop anymore because it runs into this cap. Now this cap can happen at the surface, where the surface is a little bit cooler because, let's say, of rain-cooled air, or possibly a sea breeze front where the Atlantic air coming in is cooler than the air right above at 9 to 25 millibars. But basically, it's a roadblock. And that's what prevents your thunderstorms from maturing. So it's all about the difference in the temperatures in the atmosphere. When you don't have that block, that's when all your cumulus starts to grow. So when you see on the satellite picture all the cumulus popping up, that's your water vapor rising in the atmosphere. And the stronger the lift, the more the thunderstorms clouds can grow. When you see that stopping, that's that cap. So it's all about temperatures and how they interact. Great question. Let's see here. We got some good ones. You're so uplifting. Well, I try. Look, Snow, I got to be honest about what the environment is. Rather than blow a bunch of false hope and say, oh, yeah, next winter's going to be amazing. I'm already seeing some knuckleheads running around posting about Arctic blasts and intense storms and winter you won't forget and blah, blah, blah. Exactly. It's July. How are you making these statements? And they got like 1 million followers. I don't get it. Some people just like to be lied to. I don't know. But I'm not going to do that with you, okay? I'm not going to tell you that something's going to happen and I have no clue if it will or not.
Don't believe the hype.
Yeah, right? Exactly. For all this solar activity, the stratosphere does not seem as cold as it would usually be. I know overall that this is the warmest time of year due to direct sunlight, surface to 850 millibars. It's so warm. But the warmer pockets of 70 millibars surprises me. Water vapor impact? I think so. Now, water vapor has... Let me drink some water here. Water vapor has an influence of causing cooling in the upper stratosphere and warming on the troposphere. But you have that layer of the lower stratosphere and upper troposphere where it's a little bit convoluted. And I think that is what we're seeing here on the 70 millibar observations. I know I'm just busting on you. I love the information. I know. It drives me nuts to see some of these people running around and making some insane statements. You know, everything from hurricanes hitting. By the way, how's that hurricane that's supposed to hit the Gulf Coast that guy put a video out? I don't get it. It annoys me only because I love this science so much. And to see individuals scare people is disgusting to me. I don't care. They can have 1 billion followers. I don't care about the followers. I care about the misinformation and the. It's one thing to be wrong about a forecast, but own it. You know, I'm sure you will have the what could go wrong list, even if we see things going our way. Yeah, I always do. Look, when it comes to seasonal forecasting, I know there's a lot of people that always say, we're the best. I'm never going to be the best. How do you be the best out of something where you're basing everything on chaos theory? It's ultimate.
Awesome, though.
I mean, the key thing is this. I do what could go wrong because I recognize I very well could be wrong. And this is how it could go wrong. By doing that, at the very least, you're prepared for that outcome. And then you could prepare accordingly. Rather than me just say, it's definitely going to do this. There's no way it's going to do anything else. I used to do that when I was younger because of my ego. And I had to learn in my 20s that you can't do that. That forget about people. Mother Nature will find a way to smack you in the face when you try to pull that stuff. So it's best to be humble and to forecast such that you probably going to end up being wrong about something. Hey Steve, piggybacking on the last question, how do you tell there's a cap restricting thunderstorm maturity? Is there a way to look at model and tell? Better than models, let me take you to a free site. And let's see here. Here it is. Okay. So this is SPC. Let me go back here. Let me see if I can go back all the way to the website itself. Okay, so this is SPC mesoscale analysis. So when you go to the SPC website, spc.noaa.gov, you're going to have mesoscale analysis. Now, under mesoscale analysis, I'll zoom in here. You can go to Cape Surface Based. This is a good starting point. And what's great about this website, which again I stress is 100% free, see these question marks? Let's see if I can drag this over here. Okay, you hit that question mark and it'll give you all the information and the equations about the CAPE and about convective inhibition. What we're talking about here is SIN, C-I-N, and this is inhibition. This is represents the negative area of a sounding that must be overcome before storm initiation can occur. And this is, as a young meteorologist, if you don't have the money to buy all the books, which I understand, you can bypass that by going to the SPC and reading all of these little question marks. Provides a great amount of information. Now, when this is the current state of the atmosphere. Now you see this is your SIN. These contours, and I believe this is blue and dark blue. Now, what this tells you is that this is the amount of energy you need to overcome to produce your thunderstorms. And that energy is in joules per kilogram. Okay, so think of CAPE kind of like your potential fuel tank and SIN as the inhibitor to reach that fuel tank. When you start to see CAPE values 2,000, 3,000 joules per kilogram, that's like nitroglycerin. And then these caps are basically separating you from reaching that nitroglycerin. So when you start to see this, notice you still have a SIN over much of the region, but it's strongest on the coast. Why? Because this is a marine air mass. So the cooler portion of the atmosphere is much deeper because you have a deeper source, as in the Atlantic Ocean. So you don't even need model guidance. You can see the observations right from there, and you can see it in different ways. We can look at it via CAPE. You could look at it as lifted index. Again, anything around -3 or higher supports severe thunderstorms. Look where we have our bullseye once again, right around the Philadelphia metro, right? But we're not seeing any thunderstorms now because we have that inhibiting cap. And again, it's strongest right along the coast where we have a stable environment. So that's where I would suggest you going to really learn about all that data, okay? Because again, it's free. And let me tell you something. I wish I had this stuff when I was younger, when I was a teenager. I didn't have any of this stuff. I went to the library. Yes, library, books everywhere. They didn't have these books. They had like books like weather in general. So if I wanted to get these books, I had to go to the Monmouth County Library, and you might be lucky to get one or two. But now you have all this data and all this information. So it's available for you to read. And once you know it, it's 9 o'clock, a little bit over. So we're going to call it a night for tonight. A couple of notes before I go. Hold on. Is disruption of the southern 700 millibar jet and 250 millibar amplification in the southern hemisphere. Southern hemisphere has no impact right now on the northern hemisphere SOI factors, at least from what I could tell. And based on the equations, it doesn't have much of a factor. So that's it for tonight. We're going to be taking a week break. I will be back. Let me go check real fast. On the 19th, Wednesday the 19th, we'll be back with another live coverage. But I'll be away for the upcoming week. So I won't be doing any live chat next week. So I will see you all on the 19th. Of course, I'll have my updates every day and video discussions every day as well. Have a wonderful night, and as always, stay safe out there.